Hi everyone, in today's video I'll teach you proving of root 2 as an irrational number. You have a format to prove it. If you understand one format, you can prove all irrational numbers easily. So look at the proving first. Try to understand this, the concept. Let root 2 be a rational number. Let root 2 be a rational number. If you cannot prove it as a rational number, means root 2 will be irrational. Then root 2 is equal to, the definition of rational number tells you that a number which can be represented in the form of p by q. So since we have assumed root 2 as a rational number, so we write it as p divides by q, where q is not equal to 0, p and q have no common factor. Or factors except 1. This is the condition you have to remember for rational numbers. Now we copy this again. Root 2 is equal to p divides by q, squaring both sides such that root gets removed from here. So we get 2 is equal to p squared divides by q squared. Now we cross multiply and write p squared is equals to twice of q squared. When we get this, you look at this part. So what do? We can make a simple assessment and remember this as 2 divides 2q squared. So 2 divides p squared, but 2 is a prime number. 2 is a prime number. This statement you have to remember as 2 divides 2q squared. We can divide 2q squared, we divide by 2, we get q squared. So since right hand side can be divided by 2, so left hand side can also be divided by 2. As 2 divides 2q squared, so 2 can divide p squared as well, which means that 2 can divide p. 2 can divide p. So first one, as 2 can divide p means we are getting a common factor. We are getting a common factor for p as well as q. So this is the first part. Now second part, again we assume it. Let p is equals to 2n. We assume this. Let p equals to 2n. Let, all you write like this, where n is an integer. When we talk about rational numbers, it is in form of p by q. Q is not equal to 0. P and q are integers, so we are assuming here. Look at the calculation. Now we substitute by substituting P is equals to 2n in equation 1. Take this one as equation number 1. So we substitute here. We get 2n whole squared equals to 2q squared. We simplify this and we get 4n squared is equals to 2q squared. From this we make q squared the subject of formula. We can cancel this 1, 2 times. So q squared is equals to 2m squared. Once you reach this step, you have to write the same thing as 2 divide 2m squared. So 2 divide q squared. Same statement, because it is similar to this equation number 1. As 2 divides 2m squared, so 2 divides q squared. Therefore, or implies 2 divide q. 2 divides q. Once you reach step number 1 and step number 2, if you look at the statement here, P and Q have no common factors except 1. 2 divides P and 2 divides Q means that P and Q have a common factor. That common factor is 2. This contradicts the assumption of rational numbers. Thus, P and Q have common factors. That is 2, because 2 divides P and 2 can divide Q. As both the terms P and Q are divided by a single number, means it has a factor, and that common factor is 2. This contradicts that P and Q have no common factor. No common factors except 1. Therefore, root 2 is not a rational number. So, root 2 is an irrational number. It's not difficult, you just need to follow the steps. Root 2, we have assumed it as rational number. So we prove it, and P and Q both have common factors too. When we have a common factor, then it contradicts the statement for rational number. So this root 2 cannot be considered as rational, so it is an irrational number. So this is the first proving. You can similarly prove root 3. Root 3. Look at the proving. To prove root 3 is an irrational number. Same concept, same steps are involved. Let root 3 be rational. Root 3 be a rational number. So we assume root 3 is equals to p by q. Since we are taking this root 3 as rational, so it has to be in form of p by q. Q is not equal to 0. P and Q have no common factors except 1. This is very important condition. P and Q have no common factors except 1. So we need to solve it and get a common factor. If we get a common factor, root 3 cannot be considered as rational. So we prove it as irrational. We square both sides. Squaring both sides gives you 3 is equals to p square divides by q square. Cross multiply. P square is equals to 3q square. We got this. Now we write here. We have 3 in front. So as 3 divides q square, so 3 can divide p square. And 3 is a prime number. First condition. So 3 divides p. We got this first statement. We take it as equation number 1. Let p is equals to 3n. We have 3 here, so we take it as 3n. By substituting in equation 1, we substitute p here. 3n whole square is equals to 3q square. It is 9n square is equals to 3q square. We cancel 3 times. We get q square is equals to 3m square. Same statement now as 3 divides 3m square. I forgot to write 3q square over there. 3m square. So 3 can divide q square as well. 3 is a prime number. 3 is a prime number, which implies that 3 divides q. Now look at this. We have 3 divides p, 3 divides q, means that we have a common factor. And since it is a common factor, so root 3 is not a rational number. Now we write, since p and q have a common factor 3, therefore root 3 is not a rational number, because it contradicts the statement here. P and Q have no common factor except 1. So P and Q we are getting a common factor as 3. So root 3 is not rational. So root 3 is an irrational. number. Second proving. Similarly, you can prove root 5, you can prove root 7, you can prove root 13, 11, and so on. So please do go through this step involved in proving of irrational numbers. You may get one question from this in exams. So you have so many things over there to prove it. Look at question number 2, exercise 1.2. I'm proving 7. To prove root 7 is an irrational number, let root 7 be a rational number. We have to get a common factor, that is the important term. Let root 7 be a rational number, so we assume root 7 is equals to p by q. Same steps. Q is not equal to 0. P and q have no common factors. Common factors except one. Condition. This is very, very important condition. Now we square both sides. Squaring both sides gives you 7 equals to p square by q square. We cross multiply. P square equals to 7q square. Equation number 1. If you look at this equation, we have 7 in front of q square. Means this quantity is divisible by 7. So as 7 divides 7q squared, so 7 divides p squared. If left hand side is divisible by 7, right hand side should also be divisible by 7, where 7 is a prime number. Which implies that 7 divides p. When it can divide p square, so it has to divide p. Something like this. Suppose you have 2 square. This 2 square is divisible by 2, suppose. So 2 should be divisible by 2. So if square is divisible by a number, then number without square has to be divisible by that particular number. Second assumption, let p is equals to, we have 7, so we assume it as 7m by substituting in equation 1. We substitute here. 7m whole square is equals to 7q square, which is equals to 49m square equals to 7q square. Cancel this. 7m square equals to q square. Arrange it. Q square is equals to 7m square. Now you write here as 7 divides 7m square, so 7 divides q square as well. It can divide left hand side, so it has to divide right hand side as well. 7 is a prime number, which implies that 7 divides q. 7 divides p, 7 divides q. It means that p and q have common factors. So we write as p and q have 7. This contradicts the statement here. Contradicts the statement P and Q have no common factor except 1. As it is contradicting, so P and Q have common factors, therefore root 7 is not a rational number. Contradiction of the definition. It has to have only 1 as factor, no common factor, whereas P and Q have common factor 7. So root 7 is not a rational number. Therefore root 7 is an irrational number. Look at this statement. Simple. Similar steps involved for all the provings. So please do practice this. Thank you very much. Stay safe.